Welcome back everyone. This particular video is in continuation of the last one we did for functions, functions part 1, where we talked about the green, the blue, the gray world and pure functions. So I tried to lay foundation for you what a pure function is, these guidelines which I talked about. So this particular video is in continuation, and here I'm going to focus on one aspect, which is how do you integrate areas which are prone to exceptions with the pure world. So I have a lot of code written here, which is mentioned on the blog and committed on JIT. But I would rather build this with you step by step, the thought process that's involved, and tell you various minute things. Not only will this help you for stitching exceptions in the correct way, it'll also help you explore various other areas of programming in F Sharp. So to start with, I'm going to open the system.io namespace, because file is what we will frequently need for IO operations. I'll focus heavily on IO operations because that's a good example of how operations may fail. And as an example, what I'll do is I'll go to D drive and I'll create files. I'll create files here, okay? Now let's first of all write a very simple function, and the job of that function should be to read all the text from the given file. So you'll say let read all text file equals to file dot read all text, and the path being let's say d files sample.txt. That's what, no, what am I doing? Sorry, this, I'll copy this, and later in the code I can say read all text, this, let file content equals to this. So this is a function which is a wrapper around read all text, which is a standard .NET library function. There are overloads available, but we don't need those overloads right now. We can use this one. Now the problem with this function is that if I just run it, it's going to crash here, and it says file not found, and so on and so forth. For the sake of simplicity, what I'm saying is, or what I'm going to do in this example is, here I will treat this portion where I'm referring to the content, I'll treat this as pure world, and the rest of the functions I'll treat them as the part of the gray impure world. So once the content is available, that's my pure world. From here I'll raise a request to get me the file contents, and the impure world handles whatever the impure world has to do. Now a very typical technique which is used right from the C++ days is to wrap things in exceptions. The problem with exceptions is that where do you find, up to what end do you propagate the exception? It's a larger than life question in the programming world. So I'm going to talk about a completely different approach here, okay? And so let me first of all isolate this into a function outside the main is what I meant. And let me do this. Let me wrap this in a try with, and I'm saying if there is any error, I don't care what the error is, So what have we done so far? What we are saying is read all text file, make an attempt. If the file content is available, what have I written with exit? Oh, I was supposed to write with ex. As a matter of fact, this is a catch-all case. What the shape it has taken is a shorthand for this. Okay, for just one case, it's a shorthand form, but ignore that. So what we are saying here is that try to read the file, and because read all text returns a string, and here we are returning a string, it's accidentally working fine, but this is not what we wish to do. What we wish to do is, in case of success, we want to return OK. If there is any doubt what is OK, please refer to one of the previous videos where I talked about the option and the result containers, where I talked about the result container being categorically used for duality. It may indicate error or success cases. So we will say in case of success, return an OK. In case of failure, return an error, which is result.error case with exception. As simple as that. So one good thing which is happening now is there is no exception being thrown, and this is what I've mentioned on the blog. You are all requested to read the blog because I spent quite a lot of time writing down my thoughts. There are two ways you can look at an error or an exception in the world of .NET F#. One is when exceptions are thrown around, when stack-based issues are involved. The other is when you are looking at exception as a piece of data. You're not doing anything special. So once you hit this case and you wrap the exception inside an error, which is the error case of result, you have converted this error, which had not been handled, into a piece of data now. Similarly, if I create another function, let write all text, which is file and content, equals to, let me just copy this, and I'll say OK file dot write all text, the file, and now I have to use because I'm calling a C# function, which are all called in a tuple fashion, content. All right, and let me just say content is, oh, I need to make it write all text. Okay, this tagging is not required. So similar, literally the same idea. One is a wrapper for reading files, and the other is a wrapper for writing files. And here, if you notice, when I read a file content, I'm not getting a string. Now I'm getting a result of string or exception. Similarly, if I try to, because that's the return type of this function, you give it a string, which is the file path, and it returns string, which is the success case, the content, or exception, which is the error case. Similarly, the write function is give me the file name and the contents of the file. I'll tell you whether I was, because this function in .NET is a void function, so it's getting translated into a unit. So result of unit or exception, unit being the file was successfully written, exception being that the operation failed. So we'll talk about the usage later. So one problem that you may observe here, which is already appearing with just two functions, in reality you will have dozens of functions for low-level operations, from making an API call over HTTP to REST calls to talking to database and so on and so forth. All of those functions live in the gray world. A common problem is that if you look carefully, this is of meaning, this much, and in this case this is of meaning. Everything else in this function is boilerplate try, success in one case, and failure, error, another case. So what I'll do is I'll just copy these functions because I've already written these, and I'll explain what is going on here. Okay, I just rewrite these. So pay attention to this function because the others are an extension of this only. Try and understand what I've done here, and the rest, everything will make sense to you. So I have created a helper function called try func1, meaning thereby try a function with one parameter, try a function with two parameters, try a function with three parameters. These are just, I could have used partial functions, but I just wanted to keep it simple for you to see what's going on. And here I'm asking for two things. Remember, I created apply over and over again and again in various examples. So what am I doing? I'm calling this function f with parameter p. If all goes well, the return value of f gets packed into OK. If it fails, we talk about error case. So if f returns b, the output of this function is result of b or exception. Simple. The other functions are nothing but if f has more than one parameter, if f has more than two parameters, and so on and so forth. So you can create more versions of it, but you know, 3 parameters is already more than sufficient for nearly all the practical cases that I can think of. Now once this function is ready, what you need to do is stop using these functions, because this is where all the repetitive story is, and then create a function like this. Create a function like this and create a function like, okay, let me just do it step by step. This is the very first version of function that we created. Remember, it's a wrapper, it's nothing but a wrapper for your system.io.file.read alt text. This function may crash. So what we then need to do is just one more step is pending in this. Now this function is try func1. Try func1 is written here, and I'm partially applying try func1 with this function. So what am I doing here? I am saying when you call this function, you get a partial application of try func1 with this. So if you have to call this function, what would you say? You will say try func1 this and some file name, let result equals to file whatever. This is how you will call this function, try func, for this one, I mean this one. Now when you just call this one, you have a partial application of this one. Remember, I talked about when the very first time I talked about partial application, I mentioned that partial application allows you to create specialized functions out of generalized functions. Now try func1 in itself is a super duper specialized function. It's full of generics and it's full of open-ended idea. Give me a function, give me a parameter, I'll call it, I'll try it. If all goes well, the return value of function gets packed in OK, lifted value. If it fails, I'll pack the value in error, and that becomes, in this case or in this case, the return value is a result. It's a super open-ended function, and it's no coincidence that the order of parameters is f and p. It's not p and f, because f, the function, is what you would like to tie up as the first thing, not the parameters. Parameters are dynamic, parameters are more changing, parameters are more context sensitive situational values. So when you partially apply try func1 with this function, you end up with another function. Let me just show you. So if I just do this is an unsafe function which I want appearing here, and when I just execute this much, I get a function which will take a string, file name in this case, and it will return a string or exception. Okay, so this is captured here. So this is the unsafe version. I can even, instead of writing it like this, I could have very well written a lambda, which I wanted to avoid so that you can clearly see. I could have done this. I did not need to create this middle function. I could have simply said fun x equals to, okay, so this is partial application of, but I didn't want to do that. I wanted you to see step by step what I think, how I approach it, so that tomorrow you can merge things depending upon your convenience and your friendliness with the advanced concepts in F sharp. But if you break it down to step by step, there is no harm. It clearly shows you what's going on. So if I call read all text, I'm calling a function which accepts the file name, which was D. So I'm just gonna say now this bit is my gray world. This is where I'll program my blue or pure world. In the blue world, what I'm saying is result equals to read all text, this file. Read all text is nothing but a partial application of this function. Sorry, this function. We have injected this function here, and the parameter, which is file name, is awaited, which is happening now. Okay, so now let's see, we say result match result with OK content, whatever will be, I'll just populate it, I'm just writing it down, or error of exception. So this is the basic structure of our try catch, and we will say, and let me just, because I want to reuse the variable result, I'm going to say this printfn. In this case, I'll say the content is content, and in this case, I'll say read operation failed with exception. So let's run this and see what happens. So it says read operation failed with, and we have a full-blown stack of error which we don't need. So I'm just going to say extra message to make it a little readable. It says read operation failed with this. So before I proceed further, I just wish to highlight a very simple thing here. In the pure world, I'm not dealing with exceptions, and what I mean by this is I am not dealing with thrown exceptions. I am not doing exception handling. I am dealing with a regular discriminated union. I am dealing with a piece of data. This results in a result of string and exception, and I apply pattern matching. In fact, I can get rid of this, and I can simply say, yeah, that's the way I like it. Every time my goal is to push more and more towards a pipeline, because that guarantees everything is pipeline ready. Okay, so I am matching the result of this with this or this. Now, not a whole lot meaningful things are happening here, but it will give you an idea of what we have done. We created a wrapper, a low level wrapper, a high level wrapper. A low level wrapper which is actually doing the dirty job, which may fail, which may crash, which may throw an error. A high level wrapper which partially applies try func1 with just the function supplied, not the parameter. Parameter is what we will supply when we call this function here. Okay, that's the beauty of partial application. And a try func1 is similar to, you know, f2 f3 is a function, a parameter. Try executing the function with the parameter. If all goes well, wrap it in OK. If it fails, wrap it in error. And now I'll copy everything else from here, because it's otherwise I'll have to retype everything. And I can get rid of the IO bit because I've already included the namespaces. So I similarly have a low level wrapper for write all text and a high level wrapper for write all text. So I'll remove this one, I'll comment this out and try writing a file. Instead of reading a file, I'll say write all text, whatever. Here comes some content. In case of OK, this function will return a unit. Why? Because this is a void function. So your void gets translated into a unit. So we don't care about the unit, so we will ignore it. The content, and in this case, I'll say the content was written or is written. And in case of error, we will say write operation failed with this, and let's see. It says the content is written, and if we go there, the file is now available. The file has here is some content, and because earlier this was failing since the file did not exist, let's see what happens this time. And you can see the content is here comes some content, which is happening from the OK case. So when we are in the pure world, because this is isolated, this is written in the impure world. Right now we are dealing with sample pieces of code where everything is part of a single file. You will break down everything into modules and structured approach, namespace and whatnot, which we'll talk about later. And in the pure world, excuse me, you focus on data and transforming data. If you look carefully, result gets translated into a string, and that string gets printed on the console. So I'll just quickly look at the block to make sure if I have not missed anything. The rationale of what I have shown you in the example, I've tried to argue the same thing on the blog, what I am doing, my approach step by step. So the summarizing points is exceptions are not the only uncertainties that you deal with when you are in the world of when you are in the gray world, and we will talk about more uncertainties as we move forward. And one of the best containers other than async, because async is a very specialized async or task. So result container is it captures the success path and the failure path and avoid flow control as much as possible. So here we are completely avoiding flow control, and here we have isolated flow control to an extremely low level helper function. We are not doing flow control even in our wrappers. Flow control is isolated, thrown in an absolutely general purpose, super generic low function. Okay. So avoid flow control, deal with data, not flow control. Figure a way out to translate flow control into data. We just discovered how exceptions or thrown exceptions can be translated into data. There are more techniques for more cases, for more aspects we will see in future. And wherever flow control is not avoidable, somewhere we had to implement the flow control. We could avoid it here, we could avoid it here, we could avoid it here, but somewhere we had to, isolate it and create wrappers. So everything that I essentially talked about and how I built it step by step is also given on the blog. Do read it, and the content, the source is committed on the blog, right? Oh, see you in the next one. Thank you.